Today's lesson is going to be on permutations. This is log page 8 in your logbook. A permutation is an arrangement of objects in which order is important. So I want you to highlight or underline is important. We can use the fundamental counting principle to evaluate permutations. So let's explain what the fundamental counting principle is. I'm going to do that with an example. Consider the letters of the word math. There are 4 letters in the word math. How many ways can we rearrange those letters? So we are going to be rearranging letters in the word math. Well, since there are 4 letters in the word math, the fundamental counting principle, and we're going to use FCP for fundamental counting principle, says the different permutations can be found by multiplying 4 times 3 times 2 times 1. And here's the reason why. There are 4 options. So there are 4 options for the first letter. I have 4 letters that I'm going to place in 4 spaces. So there's 4 options for this first letter. I can put the M, the A, the T, or the H in the first spot. Once I pick a letter for the first spot, then there are only 3 options for the second spot. And once I pick a letter for the first and the second spot, then there are only 2 options for the third spot. And then that only leaves 1 option left for the last spot. And then we're going to multiply those together. And when we multiply 4 times 3 times 2 times 1, we get 24. So there are 24 ways to rearrange the word math. The letters of the word math. That's what we're going to say. There are 24 ways to rearrange the letters of the word M-A-T-H. Order is very important here. Since all that we're doing is rearranging things, order matters. Order matters because ATMH is the same as HATM, the same letters, but they're in a different order. So the order is what matters. The order has changed. That's what we're doing. We're looking for different ways to put these letters in a different order. So since all we're doing is rearranging, the order matters. So highlight, underline, order is important with permutations. So permutations, order is important. Okay, there are 2 different options, ATMH and HATM. Let's look at the next example. What if we're given 7 boys on a sports team, and we want those 7 boys to line up to take a picture? We want them side by side. So we have 7, 1, 2, 3, 4, 5, 6, 7. We want 7 boys to line up to take a picture. Well, there are 7 options for who stands first. But once somebody's picked, there are only 6 ways for somebody to be in the second spot. Then 5 ways for the third, 4 ways for the fourth, 3 for the fifth, 2 for the sixth, and only 1 person left for the 7th spot. And then we're going to multiply all of these together. So we're going to go to our calculator now and do 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,000, see if I can scoot this over, 40 ways to line them up. So there's 5,040 ways to line up 7 boys side by side for a picture. Okay, let's look at example 3. How many different arrangements of the word dinosaur are possible? Okay, so let's look at the word dinosaur. One, two, three, four, five, six, seven, 8. So there are 1, 2, 3, 4, 5, 6, 7, 8 letters. If all I'm going to do is make different arrangements, then I can pick any one of these 8 letters for the first spot, 7 for the second, 6, 5, 4, 3, 2, and 1. And then we're going to be multiplying all these together. Now, I hope that you will notice that this is actually the same thing as 8 factorial. So another way that we could use our calculator to evaluate this is to do 8 math over to probability down to number 4 to get the factorial and hit enter. So this is 40,320 different arrangements. Of the word dinosaur. Okay. How many different arrangements for the word dinosaur would be possible if we only used 3 letters? So 1, 2, 3. We only want to use 3 letters of the word dinosaur and see how many different ways we could arrange these 3 letters, or three letters, not just the 3 letters from the word dinosaur, but any 3 letters from the word dinosaur. Well, there are 8 letters in the word dinosaur to pick from for this first space. So there are 8 there. Then, once I've picked one of these letters, there's only 7 for the second space. And then, once I've picked 2 of these, there is only 6 left for the third space. And since I'm only using 3, I'm going to stop right there. I'm not going to multiply anymore. So 8 times 7 times 6 is 336 ways. There are 336 ways to pick 3 letters from the word dinosaur and line them up. Now, besides the fundamental counting principle, there is also a formula, and I know you guys don't love formulas, but there is a formula that we can use, and you do need to learn the formula. Okay, so besides the fundamental counting principle, there is also a formula. So we're going to have both. We're going to be using factorials because we just hopefully recognized that we could use factorials to find our answer just as easily as multiplying all those together. All right, so let's learn some mathanese. N, capital P, and a little r. A lowercase n, a capital P, and a lowercase r means N permutate R. This is the symbol in mathanese that tells me to find all of the arrangements of N things taken R at a time. Notice in your PowerPoint that it says N is the total number of objects to pick from. So if we're thinking about our last problem, that would have been the number of letters in dinosaur. That would have been the number of letters in the word dinosaur. And then the R is the number of objects that I'm actually using. So in the last example, R is the number of objects that I'm actually using, so I was using 3 letters. So the N would have been 8 because there were 8 letters in the word dinosaur, and the R would be 3 because I was going to use 3 of them. Now my formula for N permutate R is N factorial divided by N minus R factorial. Now this only works if items are not repeated, because if I had something that was being repeated, then my numbers would not be decreasing because I could still use that number. It's kind of like with phone numbers. I can reuse numbers. I can have 2 3s in my phone number, but we're going to only be using this formula when things are not repeated. Not repeated. So let's look at an example of how we're going to use this formula. Slide this up just a minute. Okay. How many different options are possible for PIN numbers, like for your debit card, if you cannot repeat numbers? We cannot repeat. When it says that I cannot repeat, then I know that I can use the fundamental counting principle or my formula. So let's do the fundamental counting principle first. How many numbers are in a debit card PIN? Well, most debit card PIN numbers have 4 numbers in it. So we're going to be picking 4 numbers. Okay, we're going to be picking 4 numbers. Now, what are we going to be picking from? Well, we're going to be picking from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the numbers that we can pick from to put in to our 4-digit PIN number. There are 10 digits here. So in the first space, I can put 10 digits. Once I've picked one of those, then I can only put 9 in the second space. Once I've picked 2, I can only put 8 in the third. And once I've picked 3, I can only put 7 in the fourth. So I'm going to do 10 times 9 times 8 times 7. And that's going to give me 5,040 PIN numbers. Okay, 5,040 PIN numbers. That's with the fundamental counting principle. Now let's do this with the formula. The formula says that I have to do n factorial over n minus r factorial. Well, n is the number of digits that I have. I have 10 digits, so that is my n. There are 10 numbers here, that's my n. So I'm going to do 10 factorial divided by 10, because that's n, minus r, which is the number of places in my PIN number. 1, 2, 3, 4. So r is equal to 4 because there are 4 places in my PIN number. Okay, so this is going to give me 10 factorial divided by 10 minus 4, which is 6 factorial. And from Friday's lesson, hopefully we remember, I hope I have enough room to write this, that I'm going to do 10 times 9 times 8 times 7 times 6 factorial. And I know because I've got 6 there, I can stop. I don't have to list anymore because 6 factorial is going to divide with 6 factorial and become 1. So now I have 10 times 9 times 8 times 7, which is the same thing I had with the fundamental counting principle. So that's going to be 5,040 PIN numbers. Okay. Now, what if numbers could repeat? What if our numbers could repeat? Let's look at that. So what if I had my 4 numbers that I'm going to put into my PIN number, and the numbers could repeat up here? I still have 10 digits, right? So I can put any 10 of them in the first spot. And if I can repeat that number, then I can put 10 of them in the second, and 10 of them in the third, and 10 of them in the fourth. Because if they can all repeat, I don't have to take that one out when I pick the next one. So now I'm going to do 10 times 10 times 10 times 10, which is 10,000 PIN numbers. Okay, so if I don't repeat the numbers, there's only 5,040 PIN numbers. But if I do repeat the numbers in each space, then I can get 10,000. I can use a number here for a PIN number like 4444 or 2336. These are ones where I can repeat. These are ones where I cannot repeat. So on PIN numbers up here, I'm going to have numbers like 5, 4, 6, 8. No repetition. So please be sure you make a distinction between when you have repetition and when you don't. All right, I'm going to stop this video now, and that'll be it for part 1, and you'll then need to go and look at part 2's video.